Welcome back. This is Mrs. Rubright with Algebra 1 Honors. Today's lesson is 6.3, Polynomials. Investigating parts of a polynomial. The parts of a polynomial that are added are called the terms of the polynomial. Each term is either a constant term is just a number, or a variable term. A variable is the product of one or more variables with a whole number exponents. Terms may have factors that are numbers, variables, or combinations of both. So numbers are obviously like 1, 2, 3, 4, right? Numbers. Variables are your letters or combinations of numbers and letters. All right, so to identify the terms of a polynomial, 4x to the third plus 2x minus 9, first rewrite the subtraction as addition. So you have 4x to the third plus 2x plus negative 9. Negative 9 is just a number, so that is your constant term. Right, your variable terms are the ones that have letters in them. Your coefficients are the numbers that are stuck in front of the letter, a number being multiplied by a letter. The variable terms of the polynomial can be broken down into a coefficient and a variable part, as shown above in the first term, 4x to the third. For the second term, 2x, 2 is the coefficient and x is the variable part. The degree of the polynomial in one variable is the greatest power of the variable. For the polynomial above, the degree is 3. It is a third degree polynomial. Because this is the third degree, first degree, right? This is 3, this is 1. The higher one is 3, so it is a third degree polynomial. Notice that the variable terms have the common factors 2x and 2x, but there is no common factors greater than 1 for all three terms. You can also have a polynomial in a variable other than x. Below is a polynomial with the variable q. All right, so like 9q, negative 3q squared, you can use any letter. Your constant is just a number, and your degree, once again, is the largest of the options. So for this one, we have a 1 versus a 2. This is going to be a second degree polynomial. What is the degree of the polynomial? Do the coefficients of the terms have any common factors? Do the variable parts of the terms have any common factors? What is the greatest common factor for all four of the terms of the polynomial? All right, so these are all in y's. So let's write them in descending order. So we have negative 4y to the fifth plus 8y to the third plus 2y squared plus 6y. Okay? So what is my degree? What's the degree? Anybody? Is it 1, 2, 3, or 5? Fifth degree. Is there a common factor, something that they all can be reduced by? So they can all be reduced like 2 is a common factor of the coefficients. And y is a common factor of the variables. So the greatest common factor is what? What's the greatest common factor? 2y, right? 2y. You can reduce everybody by 2y. All right, so here's another one. It has two variables. The degree of any term is the sum of the exponents of the variables. The degree of the polynomial is the degree of the term with the greatest degree. Find the degree of each term of this polynomial and the degree of the polynomial. So here, this is the fourth, right? Here, this is 4 plus 3, 7. 5 plus 1, 6. What number is the greatest? Is it 4, 7, or 6? 7. So this is a 7th degree polynomial. Writing polynomials in standard form lets you easily identify characteristics of and compare different polynomials. Polynomials in one variable are written in standard form. When the terms are in order from greatest degree to least degree, right? In standard form, we always write from greatest to least. Standard form also makes it easy to compare the leading coefficients of the two polynomials or the coefficients of the first terms. All right, so writing this in descending order. So we would have 2y to the fourth, 4, then the 2, then the 1, and then the constant, just a number, right? Writing it in descending order. Fourth, second, first, just a number. The polynomial has how many terms? 1, 2, 3, 4 terms, right? The terms and their degrees are 16y would be what? Degree what? 16y is degree 1. 2y is degree 4. 11 is degree 0. Negative 3y squared is degree 2. The term with the highest degree is, what's the term with the highest degree? 2y to the fourth, right? So the polynomial has degree 4. The polynomial written in standard form is 2y to the fourth minus 3y squared plus 16y plus 11. The leading coefficient of the polynomial is 2. The first number, right? That's attached to the ladder of the highest term. Notice that the number of terms is the same as the degree of the polynomial in the example. Is this true for all polynomials? Explain. The number of terms is equal to the degree of the polynomial. Is this always true? No. The number of terms and the degree of the polynomial are not always the same. So like if you had, for example, so I'm going to give an example, 5x squared plus 7x plus 4 has 3 terms and it's second degree. Right? It's the degree is 2 and it has 3 terms. It's an example that's like a counterexample proving that that's not always true. A trinomial is a polynomial that has 3 terms. What possible degrees can a trinomial have? Consider that each term has a different exponent and that the exponents are whole numbers. Explain. The least degree is 2 because to have 3 terms, the lowest exponents must be 0, 1, and 2. Any degree above 2 is also possible. Because you don't have to have every degree, right? Polynomials often contain letters other than variables that are specific values depending on a particular situation. These values are often referred to as parameters. For ax plus b, a general linear polynomial in the variable of x, the letters a and b are parameters. The parameters a equals 50 and b equals 100 gives 5x plus 100. This might represent, for example, the total cost of a gym that has a monthly cost of $50 and a membership fee of $100. The quadratic polynomial negative 1/2 a t to the squared plus v sub 0 t plus h sub 0 is a polynomial in the variable of t for time. It represents the height of a projectile launched upward in the presence of gravity. The parameters a, v sub 0, and h sub 0 represent the acceleration caused by gravity in a location. the initial upward velocity, and the initial height. Once you know the parameters for a given situation, you can find the heights for different values of the variable t. A compressed air model rocket is launched straight into the air from a platform 3 feet above the ground at an initial upward velocity of 350 feet per second. The height of the rocket in feet, t seconds after it's being launched, is modeled by blah, blah, blah. Interpret each term in the polynomial, then use unit analysis to show how the value of the polynomial is a distance in feet. The terms of the polynomial are, so what terms do we have? Negative 16t squared. What else? 350t and 3, right? The term blank depends on the acceleration of gravity times the blank. Which term? The term negative 16t squared depends on the acceleration of gravity times the square of time in seconds after the rocket is launched. The term 350t is the initial upward velocity times the time in seconds after the rocket is launched. The term 3 is the height in feet from which the rocket was launched. To use unit analysis, write the polynomial with its units, then divide out any common units. Okay, so we have feet times second squared over second squared, feet, seconds, feet, 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 feet. Okay, so these are going to cancel each other out. These cancel each other out. So you're left in feet, feet, feet. So these will cancel out. Suppose the model rocket, an example, is launched from a platform of 10 feet above the ground at the same initial upward velocity. Explain how the polynomial that models the height in feet of this rocket t seconds after the rocket is launched differs from the polynomial in the example. So the constant term would be 10 instead of 3, right? Suppose the model rocket, an example, is launched from a platform 9 inches above the ground. Does the polynomial correctly model the height of the rocket in feet t seconds after it's been launched? No, because 9 inches needs to be converted into feet first, right? So you would do 9 inches. You need to get out of inches and into feet, right? There's 12 inches in a foot. For dimensional analysis, your units have to be diagonal to cancel out. So 9 over 12 is... 3 goes in here 3 times, 3 goes in here 4 times, 3/4 feet, which is 0.75 feet, right? So you wouldn't use 9, you would use 0.75. So right here, this should be a negative 16t squared plus 350t plus 0.75. That would be correct. It has to be in the same units. So feet, not inches. Practice. For each polynomial, find the variable terms and their coefficients, any constant terms, the degree of the polynomial. If all the terms of the polynomial have common factors greater than 1, find the greatest common factor of the terms. All right, so your variable terms, 6x and negative 4x to the third. Constant terms, 14. Coefficient, 6. Coefficient, negative 4. Greatest common factor. Can these all be reduced by something? 2. What degree? Third degree. All right, so we have a 1, a 3, a 2, and a 4. What degree? Fourth degree. Variable terms, negative 12t, negative 24t to the third, 18t squared, negative 30t to the fourth, coefficient, 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 coefficient. I just circled the coefficients and put circled coefficients. All right, constant terms, none. Greatest common factor. Isn't that like 6? 6t. You can pull out a 6 and a t, right? 6t. Three, 2. This is 3, 3, 2, 3. 3. Third degree. No constants, variables, x to the third, 3x squared y, 3xy squared, y cubed. Coefficients. So it's going to be, the first one is a 1, 3, 3, 1, right? 1, 3, 3, 1. There's an imaginary 1 out front of those. Greatest common factor. You can't pull an x out of everywhere because that doesn't have an x. You can't pull a y out of everywhere. And you can't pull a number. So none. There's no greatest common factor. Right? None. Or 1. I guess technically 1. But 1 doesn't do anything. Just say 1. But 1 doesn't do anything, right? So it's like useless. Write each polynomial in standard form. Identify the degree and the leading coefficient of the polynomial. 6, 3, 1. So it's going to be the 6. Then it's going to be the 3. Then it's going to be the 1. And then just the number. That's the standard form. What degree? 6th degree. Leading coefficient? 2. Right? This number right here. Try the next one. Did you guys get x to the 8th minus x to the 6th minus x to the 4th plus x squared plus x, 8th degree, leading coefficient 1. We okay on that? Let's do the next one. Try the next one. Alright, so I got negative y to the 5th plus 3.4y to the 4th plus 2.2y cubed minus 1.6. It is a 5th degree and your leading coefficient is negative 1. A compressed air model rocket is launched straight up into the air from a platform of 1.4 meters above the ground with an initial upward velocity of 107 meters per second. The height of the rocket in meters t seconds after the rocket is launched is modeled by this. Interpret each term of the polynomial. Okay, so negative 4.9 t squared depends on the acceleration of gravity times the square of the time in seconds after the rocket is launched. 107 t is the initial upward velocity times the time in seconds after the rocket is launched. 1.4 is the height in meters from which the rocket was launched. Use unit analysis to show the value of the polynomial is a distance in meters. Okay, so negative 4.9 meters per second squared times time per second squared plus...
Good morning, and sorry for the interruption. This information is for our adult technical college students. Are you lacking financial resources or need help balancing schoolwork and family? TRIO and ATC are offering a Breakthrough the Barriers Financial Aid Workshop on Thursday, October 11, 2018 from 9 a.m. to 12 p.m. in Building 2, Room 122. All adult students, including DDB, are invited to this free workshop. Let us help you overcome barriers to success and see your counselor and office of student affairs for more information. Also, if you need to step into a new career or a job, the Community Job Fair 2018 will be held on Friday, October 19th, 9 a.m. to noon on the Ash campus. October 19th is a planning day. No classes for students. It's the perfect time for the job fair to be held. Participation is free, but you must register if you plan to attend. If you need more information, see Nicole Willis, our career advisor, in the Career Center in Building 10. In your classroom, you should see a poster regarding industry credential reimbursement for 2018-19. Check with your teacher to be sure the credential is on the approved list. And once you've filled out the application with the required attachments, bring all of your paperwork to Building 10, Office of Student Affairs, for this control. All requests must be submitted before the deadline. We are here to help you meet your success goals, so the sooner you pass those exams, the sooner you get reimbursed. The Learning Commons will be closed through Thursday of next week. ATC's accreditation visiting team, COE or CO, will be on our campus starting Monday evening through Wednesday afternoon. They will be wearing ACC badges and will be reviewing the CCD programs and talking to teachers and students throughout the campus. Your instructor will be able to give you more details about the visit. Teachers, since your classroom doors will be locked, when they knock, please open your door and welcome them. Lastly, all students and staff must wear their ID at all times. Additionally, all classroom doors must be locked always. It is a requirement that we all follow the safety and security measures set forth at our school. So to let you know, we will be updating our adult college students 2 times per week to keep you in the loop of what's important to you. Thank you for your attention and have a great evening.
All right, so back to this. So if they are diagonal, if one's on the numerator and one's on the denominator, they cancel out, leaving you with this. And that is everything for our lesson on 6.3, polynomials. I hope you guys enjoyed the lesson. Please like and subscribe and have a fantastic day.